Alright, so this video is going to be about solving equations using the addition and subtraction properties of equality. So we're going to be looking at things like determining whether a number is a solution to an equation, and then solving those equations using either the addition or subtraction properties of equality, and ultimately moving on to what we always finish with, so translating those word phrases into equations and then solving them. So when we're talking about solutions to algebraic equations, what we're saying is that we have a value in a variable that makes a statement true in terms of the left side is equal to the right side, and that holds to be correct. So the process of finding such a solution is called solving the equation. And so you can see here, if we have x plus 2 equals 7, there's only one value of x that could satisfy that relationship and say that the actual expression or equation holds true. And so if I have 7 on the right hand side, then I need something plus 2 on the left hand side that equals 7. And so the only number that would satisfy that would be 5. And so therefore the solution to the expression or equation x plus 2 equals 7 is 5. And so that would be how we approach that. So we've got the three lines, x plus 2 equals 7, therefore 5 plus 2 equals 7. And ultimately, once we simplify 5 plus 2, we get 7 equals 7. So the steps to actually determining whether a number is a solution, we want to first substitute the number for the variable in the equation, then simplify any expressions that we can on both sides of the equation, and then determine whether the resulting equation is true or false. So if it's false, the number is obviously not going to fit the profile of a solution, and if it's true, then that number is a solution. So, determine whether x equals 5 is a solution of 6x minus 17 equals 16. So, we're looking to see whether x equaling 5 makes this equation true on both sides. So, the first thing I would always do is set out with brackets, like I was talking about in the last video 2.1, the actual equation. And if you don't know what I'm talking about here, I would implore you to jump back on over to 2.2 and check out our video on simplifying algebraic equations. And so determine whether x equals 5 is a solution. So we want to plug in x equals 5 wherever we see an x. So therefore, simplifying that, we get 30. So 6 times 5 is going to be 30 minus 17 equals 16. There's nothing we can do on the right hand side to simplify it. Now 30 minus 17, that's going to be 13. 13 equals 16. Now we've simplified everything. We have to check, is this actual equation true? Does this statement make sense? 13 equals 16. Well, 13 can't equal 16 because it's not 16. And so we put a line through, remembering that this means does not equal. And so therefore x is not a solution. X equals 5 is not a solution, I should say. Determine whether y equals 2 is a solution of 6y minus 4 equals 5y minus 2. And so exact same steps as the last one. We want to set up our equation with our brackets. And then we want to substitute our number in. And so y equals 2, therefore we substitute that in. This time we have both sides of the equation that we can simplify. And so I'll do this all in one step, but we do need to remember our order of operations. So I'm going to do brackets and then indices and then multiplication and division and then addition and subtraction. And so 6 times 2 is 12, minus 4 is 8. Then we have 5 times 2 is 10, minus 2 is 8. And then we bring down that equal sign. 8 equals 8. Is this a true statement? Yes, it is. Therefore, y equals 2 is a solution. So the subtraction property of equality. So all this says is that if I subtract the same thing from both sides of the equation, then I'm still having a valid equation. So it doesn't actually change the equality. And so this will become more clear in a second, but ultimately the steps that we need are you need to use the subtraction property of equality to isolate the variable. Then we want to simplify the expressions on both sides of the equation and check the solution. And so the best way to work through this is through an example. So solve x plus 8 equals 17. And so this is where we can't solve, we're not given a number. So we're not determining whether x equals 5 is a solution to this problem. What we're doing is we're saying, okay, we've been given x plus 8 equals 17. Can we find out what x is? And so this is where the subtraction property comes in. And so if we have something added, remember that addition and subtraction are inverse operations. So to undo addition, we can subtract. And so that's all we're doing. We're subtracting 8 in this example from x so that we end up with this cancelling, and therefore we're left with x. But to ensure that this equation is still balanced, it still retains the same equality, we then would have to subtract 8 from the other side. And so we always have to do the same thing to both sides. We can't just do it for one, because then we're actually changing the values. And so x plus 8 minus 8, well, the plus 8 minus 8 becomes 0, and so nothing there. So we would just have x. Now 17 minus 8 doesn't equal 0, and so it will change the value, and we'll get x is equal to 9. And so this is a solution, or is the solution, to x plus 8 equals 17. And to prove that, we can substitute it back in. And so if I substitute x equals 9 back into that equation, I would get 9 plus 8, which equals 17, and therefore that's true. And so we know that x equals 9 is the solution. And so the way that we solve in this example is not by getting given a value to try and test it out. It's by just using our subtraction property to remove that number that's been added to x, so we can isolate x. And the ultimate aim of any of these problems is to isolate x and find out what it equals. So solve 100 equals y plus 74. And so this looks a bit backwards, but it doesn't actually make a difference. And so if we've got something added to a variable, we know that we can remove it through the inverse operation of subtraction. And so we want to isolate y, so we'll subtract the same amount that's being added currently. And so plus 74 means we want to minus 74, so that these go away. Now we have to do that to both sides. And then 100 minus 74 equals 26, therefore 26 equals y. And so most of the time you'll see this written around this way, and so I'll prefer that as an answer. And so y equals 26 is a solution. 26 plus 74 does equal 100. And so that's a good way to check to make sure you've done it correctly. Now the same thing holds true for addition. So if something is subtracted from a variable and we want to solve for that variable, we can add to both sides. And so that retains the equality also. And so the steps here are the same. We're just using addition. And so it's quite important that you're making these connections, because these are inverse properties, therefore they have the same operations that we can do, or there's the same properties that we can do. And so x minus 5 equals 8. And so this time, instead of being added, we've got it subtracted. So we would add to remove it. So that cancels, and then we just have to do the same thing to both sides. And so x minus 5 plus 5 is just x. And then 8 plus 5 is 13. Therefore x equals 13 is the solution to x minus 5 equals 8. If we want to check our work, we can say 13 minus 5 should equal 8, and it does. 27 equals a minus 16. And so the 16 is being subtracted from a, so we want to add that to remove that. Now I'm going to rewrite this a little bit. So we want to make sure we add our 16 to both sides, and then I'm going to put a on the left-hand side. That's the preferred way of doing it, and it is the standard. And so 27 plus 16 is equal to 43. And so the solution to that would be a equals 43. And to check that, we substitute in that 43, and we say 43 minus 16, and that does equal 27, so we have got that correct. All right, so translating word phrases to algebraic equations. So instead of being expressions like we talked about in the last video, we're looking at equations. And so we're looking for words that mean equals. So these are things like is equal to, is the same as, is, gives, was, will be, any of these kind of expressions or word phrases. We're really looking for those. And so translate the sentence into an algebraic equation. The sum of 6 and 9 is 15. And so, really reiterating on our previous lectures, we know that sum means add. And so we're looking to add 6 and 9. So we know that that's how that we would line up that expression. Now we've got the word is, which means equals. And so is 15 means equals 15. And so we have 6 plus 9 equals 15. And so just to check if this is true, we do get 15 on the left-hand side and we get 15 on the right-hand side. Therefore, it is correct. Translate the sentence into an algebraic equation. The product of 8 and 7 is 56. So you should be getting good at these by now. So product means multiply. And so we're multiplying 8 and 7. So we go 8.7 or 8 bracket and then 7 inside the brackets, whatever you prefer. And then is, remember that means equals. And so 8 times 7 equals 56. And we don't actually have to simplify it here, but 8 times 7 does equal 56. And so it is a true expression or equation. So same thing, twice the difference of x and 3 gives 18. All right, so going from left to right, twice the difference of x and 3. And so this one can be kind of tricky, but if we want to multiply by 2, so twice means 2, and then we multiply the difference of x and 3. So we need the difference to be in brackets because we want to calculate that first. And so the difference is subtraction, so x minus 3. Then we want to multiply that by 2. Now, if it says gives is also another word for equals. You won't see it as commonly, but it does mean equals. And so 2 bracket x minus 3 equals 18. Translate and solve this time. So we're doing an extra step in this one. We're actually solving. So 3 more than x is equal to 47. And so this one, 3 more than x means x plus 3. And now equal to is quite obvious in that one. So we've just got the equal sign. It's in the word. X equals 47. X plus 3 equals 47, sorry. And so I'd like you to try to solve this first. But if I was going to do this, there's something added. Therefore, I need to use the inverse operation or the subtraction property. And so we want to cancel those, but we have to do that to both sides. And so we end up with x is equal to 44. And so this should make intuitive sense. Remember that if I have some variable plus 3 is equal to a number, I just need to think about what that number could be to make that expression true. And so 44 plus 3 does equal 47, so it makes sense. But this is the mathematical way to find out that and prove it. Translate and solve. The difference of y and 14 is 18. So the difference of y and 14, remember that's y minus 14. And is, that means equals, and then we've got the number 18. Now to solve that, we've got something subtracted, so we want to add. So we've got plus 14, which cancels that. We've got to make sure that we add it to both sides of the equation. So then we get y is equal to 32. And so just to check our work, we should get 32 minus 14 is equal to 18, and that is true. So y equals 32 is the solution there. So that one was a nice quick one, but very, very important. So remembering the key points from today. If you have something added to a variable, you can remove it by subtracting it. If you have something subtracted from a variable, you can remove it by adding it. This allows you to solve for that variable. The aim of the game is to isolate that variable on one side and have everything else on the other side. And therefore you can say that that is a solution of the equation, or you can say that that's a solution in terms of x or y or whatever the variable is. Awesome. We'll see you in the next one, which will be on finding multiples and factors.